Okay, here we are with another video for the 8th grade talking about Newton's laws. I'm sorry, I made a video yesterday while I was riding around, but it wouldn't upload. So making a new one, and I'm not going outside to do this one because on April 18th it is snowing in upstate New York. And I mean snowing, snowing. We have a couple inches and it's not slowing down. So, Newton's laws. Law number two is where we're at right now, and that is the F equals ma. Although I do remember telling you in the last video that it's really not necessarily F equals ma. What Newton said was acceleration of an object is equal to the net force acting on the object divided by the mass of the object. So what that would mean is if I have an object like this bottle that is found laying on the table here, some kind of lotion, that there's always forces acting on everything. And right now, gravity is pulling this down towards the ground, but my arm is holding it back up. So there's two opposing forces that balance out, right? And there's a mass of this object which is being pulled down, which gives it weight. And actually, when we talk about the force of gravity, we're talking about the weight of this object, right? How the mass is being affected by gravity, and weight is in newtons, right? And I am countering that with my arm. So right now it's not accelerating, right? If I was to remove my hand from the situation and let it fall, it would accelerate because the only force acting on it, the net force, is towards the ground. Now, this object and this object do not have the same mass, okay? If I was to push this object or push this object with the same amount of force, they would not accelerate with the exact. You know what? I'm going to stop right there for a minute. And I'm going to ask you a question. And I want you to put your answer in below. Or if you're on Google Classroom with me, you can do it in Google Classroom. Or email it to me at sfife@worcestercs.org. I just said that different forces or the same force on different masses will not cause them, or will cause them to accelerate differently. However, I believe if you were to take both of these objects and drop them, they would hit the ground at the exact same time. In fact, there's a great video you can watch, and I'll see if I can't find a way to get it in my playlist. But if you look up feather and bowling ball falling, you can actually see them both fall at the exact same time in a vacuum because the only force acting on them is gravity. So why would it be that if we apply the same force to two different masses, that they will accelerate to the ground at the exact same time? Because it's not true on the horizontal for sure. If I was to push a bowling ball with the same force that I was to push a kickball, the kickball would accelerate much quicker, right? Would accelerate more than the bowling ball would. And I think you would agree that the same thing goes to how much force is needed to slow down a larger object. So if there is a train accelerating at me or a bicycle accelerating at me at the same acceleration, how much force would it take for me to stop the bicycle versus how much force would it take me to stop the train? And the obvious answer is more force is needed to move or stop a larger object with more mass. Remember, we talked about mass as being the same as inertia. So an object with more mass has more inertia. It doesn't want to slow down. So you have to use more force to stop it. And it doesn't want to start moving. So it takes more force to get it to start moving. And that should make sense. Okay? So really, when we think about second law, I want you to think about the fact that it's going to take more force to move something that has got more inertia or more mass. Okay? And the more force we apply in it or towards it, the more acceleration we're going to get. So if I was to hit a baseball with a small little force, it would not accelerate very fast and go very far. But if I was to hit a baseball with a lot of force, it will go a lot further. Okay? That all should make sense. So my video is coming to an end because I said no more than 5 minutes. So please try to answer that question about objects falling to the ground, and we'll see if we can come up with an answer in another video.